Okay, student, we continue our topic in instantaneous AC power and average power. The instantaneous power changes with time and is therefore difficult to measure. The average power is more convenient to measure. In fact, the wattmeter, the instrument for measuring power, responds to average power. By definition, the average power is the average of the instantaneous power over one period. Okay, from the equation of instantaneous power, okay, we have here P equals to V multiplied by I. So the average power actually is from the integration of the instantaneous power over one period. By averaging, you just substitute the equation from the instantaneous power to the average power equation. So when you substitute the equation, you get the answer. Okay, for the first part, IT over the first part here over half Vm Im cos theta v minus theta I. So the second part, same, IT I over T integration of the second part of the instantaneous power equation. So the result you get here is, okay, when you, for the first part here, and the second part is here. When do the integration for the second part, the value is, you get the zero value because it can be cancelled out by the positive cycle and negative cycle. Okay, so the remain here for the average power is half Vm Im cos in bracket theta v minus theta I. Okay, when you do the comparison from the instantaneous power equation, okay, so which part that remain the same equation in the, if you see here, is the constant part. So for the average power, actually the others name you can derive it as a constant part from the instantaneous power. Okay, so here I show you, okay, here I show you, okay, you can read here all the description about this progress rate, this step of integration. So the others name actually for the average power, okay, we call it as a constant part from the instantaneous power, okay, here, okay. The others name is, we call it as a real power measured in watts, okay, or you can just put W. Okay, student, in this slide, I want to show you the graph of the instantaneous AC power. From the graph, it's divided into two parts. The first positive part and the second one is a negative part. Okay, so where's the average power located? It is here at the negative part. Okay, so the average power is from here. Okay, from the positive part, okay, described here, the positive part of the graph indicates the power is absorbed by the circuit. From the negative part of the graph, of the instantaneous graph, indicates that the power is absorbed by the source. That is, power is transferred from the circuit to the source. This is possible because the storage element of capacitance and inductance, because of charging and discharging, if you can remember. From the average power equation, student, okay, as you learned before, okay, so P equals to Im Vm cos theta v minus theta I. So actually, it's a real part of the V multiplication of I. Okay, V and I here is considered from the sinusoidal equation. Okay, when you have the V here, Vm theta V and Im theta I. So for the average power, the equation is half V multiplied by I. Don't forget the I is a conjugate. So when you reach back in the equation, so you get half, okay, Vm theta V in the bracket, also Im theta I. So when you do the multiplication, the angle is by the addition, right? So by the conjugate here, it's become as a minus. Okay, so you get half Vm I m theta v minus theta I. So the rectangular form, you can rearrange back in the rectangular form. You get half Vm Im cos theta v minus theta I plus j sine theta v minus theta I. So you have the real part here and the imaginary part here. For the average power, we consider only on the real part only. Okay, so this is short form how to illustrate from the rectangular form here. Okay. So below I describe more about this. Okay, so when you have a resistance value, okay, the angle for the theta v and theta I is 0 degrees because, okay, if you can remember or still remember, okay, for the graph of v and I for the resistance, that's mean what? That's mean v and I sinusoid in same phase. That means when V is 30 degrees, I also is 30 degrees. That means it's reside in same phase for both V and I. So you get the subtraction equals to 0. So when you substitute the value, the theta V and theta I, the value of theta V and theta I in the average value in the resistance, you get cos theta equals to 0 degrees. And cos theta equals to 1 when you do the you measure in calculator. So the rest remain is half Vm Im only, okay, because cos theta equals to 1. So note that from the Ohm's law, Vm equals to IR. So substitute the value in this one, okay, substitute the value in this one. So when you can also get the value is half Im to the power of 2 multiplied by R, or half to the modulus value of the I, so the power of 2 multiplied by R, sorry for that. So you can get the value from this equation also, from this equation also. Remember, in this one, that's mean you just get the value from the magnitude, not the angle, okay? So uh, power average P is not time dependent because you not include the value of the imaginary part. Okay, so when theta V equals theta I, that means same phase for the resistance only. So it is purely a resistive load case. Okay, this case is namely as a purely resistive load case. For the next case is when theta V minus theta I equals to plus minus 90 degrees, it is a purely a reactive load case. That means inductance and capacitance. Okay, when if you remember back. Okay, so when you have the capacitance, okay, capacitance value, that's mean V and I is not in phase. Okay, it's out of phase about 90 degrees each other. So when you include in the equation half Vm cos theta V minus theta I, you get minus 90 degrees for the capacitance. So you get 0 watts. Okay, so for the inductance, same. Inductance V and I is positive 90 degrees. Theta V and theta I have a different phase, or phase of 90 degrees. So same, cos 90 degrees or positive 90 degrees is 0 watts. Okay, so in this case we call it a purely reactive load case. Okay, that means V and I in the same, sorry, V and I is out of 90 degrees of the phase angle. Okay, so what that means is purely reactive. That means P equals to 0, means that the circuit absorbs no average power because the power average is 0 volts. Okay. Okay, so then we proceed to example. Okay, calculate the instantaneous power and average power absorbed by a passive linear circuit if the given Vt equals to Xt cos in bracket tan t plus 20 degrees, It equals to 15 sine in bracket tan t plus 60 degrees. Okay, solution. As usual, you must choose first. Okay, both equation is in cosine. Okay, for me, it's a better, or is a more simple. Okay, so here you can get active, the angle is 20 degrees. The second one, when you change to cosine function, you must subtract by 90 degrees. You get here 15 become the angle is minus 30 degrees. Okay, so when you define the, now you want to define the instantaneous power, so just put back the instantaneous equation back. So you just rearrange back, okay, the equation, okay, from the value you get from here and here. Okay, so you get here So Vm put back the equation here, okay? So Vm Im. So here don't forget, okay? So rearrange back your equation. So you get the last result is 385.7, and the second part is 300. Okay, if you remember, this one is a constant part, or the other name is average part, average value lah. Okay, P is to 385.7 watts, okay, the average power flow, okay. So remember, the average power is the constant part of the instantaneous power. Okay, we continue to example 3. The question asks you to calculate the average power. Okay, given to you is Z, impedance, and the voltage, okay, the source. So the solution here, okay, for the average power, you have the equation here, okay. So okay, now you have the information, you have only Z and V. So the equation now you have, we have PMIM, right? So you must determine first the I from the Ohm's law. I equals to V equals to I and Z, and I equals to V over Z. So determine the value for I first. So you get the here the value. So the average power, substitute back the value of you get from V and I here, okay, in the average power equation. So the last result you will get 37.25 volts. Okay, this is a very straightforward question. Okay, for the example 4 is given to you a very simple series circuit. Here the question asks you to determine the average power. Okay, the power by the supplied by the source, and average power absorbed by the resistor. Okay, two terms, two different terms. Average power supplied by the source and average power absorbed by the resistor. Okay, how to solve? Okay, it's given to you. Okay, the series circuit here. Okay, so determine first the current I, because the average power you have the equation Vm and Im, right? So from the given information, you just determine the I by using Ohm's law. Okay, you put the value of V and Z here. So you determine the value of current here. Okay, so by now you can get the average power value supplied by the voltage source. Okay, just put back the average power equation here. Okay, put back the value of V and I, so you get 2.5 watts, okay, for the average power of this circuit. So the second question asking you to determine the average power supplied by the resistor. Okay, supplied by the resistor. Then the first option you can get is solve for the current and voltage for the resistor. Okay, remember from the equation of the P of the resistance, you have half Vmi Im. So determine first. Okay, how about the I remember this circuit is a series circuit. So I here is same for the resistance value also. No need to determine. Okay, just get the value from the first equation you have solved it. So for the V, okay, for the voltage of the resistance, you by using Ohm's law, okay, V equals to I IR. So put the I, put the value of R is a 4 ohm here. So you get the value of 4.48. The angle is 56.57 volts, okay, for the voltage. So how about the average power of the resistance? Put back the equation here because you want to determine VIMM already. Okay, so you get the value. So now you put back the value of the result. So you get 2.5 volt. Actually, the value is same for the average power here you get from the supply voltage. So here, remember the value of power absorbed by the resistance is same which the average power supplied by the voltage source. Zero average power absorbed by the capacitor. Remember, we just focus for the power is focused on the rear part of the rear part of the average power. That's mean in the rear part. So how about the capacitance? Is a purely reactive, or because the capacitor will give to you the average power is 0 watts. Okay. Okay, for the summary, at the end of the chapter, students should be able to understand the average power or real power is equal to average power is half Vmin cos theta V minus theta I. The unit is in watts, okay, or W. So the purely resistive, the angle, sorry, the angle of the current and voltage is 0 degrees because in the same phase. Okay, so the average power is depend on this equation. Okay, we have done already the exercise last slide. Okay, so purely reactive, yes, the angle theta V and theta I is what? Is out of phase of 90 degrees. Okay, so the average power is equal to 0 watts. Okay, so the equation is come from here for the inductors and the for capacitance. Okay, so P equals to 0 watts means that the circuit absorbs no average power. Okay, thank you.